Thanks a lot for having me. I'm very excited to be part of the Brain Initiative talks. Welcome to Dissemination of Optical Imaging Technologies. My name is P.Britz. I'm with NIREX GmbH in Germany. Today, I want to talk about the factors and strategies impacting the dissemination of optical imaging technologies, specifically FMEARs. To do so, I would like to give a quick introduction to FMEARs. And then I want to address the barriers to dissemination and make it a two-part problem or challenge. The first is getting the inventions into the research market and showing how NIREX approaches this. And then the second is how to get the clinical understanding to make clinical impact. We have to talk about how to overcome the so-called valley of death. And I will give one example of a successful collaboration. I think does a good job in achieving that. About me, I was 8 years a researcher, mostly focused on EEG, did my PhD on the methods for combining EEG and fMRI, and then I switched to industry, actually to the company that I was a customer of for 8 years, and built and led two companies focused on the dissemination of research equipment, including the market-leading supplier of EEG research equipment. But it wasn't only EEG. I worked with several companies and facilitated the market entry for brain imaging and brain stimulation tools, including FMEARs. And so I got to work with NIREX and knew them since a while. And I could see how FMEARs technology was very successful in various regards. Of course, in acquiring funding in our industry, we look at the NIH and see where research is going. But it was also successful in terms of being widely adopted quickly and being successful in being used. And then I was looking for a FMEARs company, and NIREX was building this equipment. I had some very international team, international locations, and building the devices in Germany, doing some of the invention in the US, and it was a very collaborative and integrative environment. So since 1 year, I'm with NIREX and the general manager of GmbH. So I will only very briefly introduce the FMEAR signal because I know that at least two brilliant FMEARs researchers have spoken before me. So we know since a long time that neural activation leads to change in blood flow, and that leads to a change in this known shape of change in the deoxy signal. And we can measure it because hemoglobin, oxy and deoxyhemoglobin have different characteristic absorption spectra, particularly in the near infrared range. Today, we want to address the barriers to dissemination. And I found a study from 2009, which states that from prioritizing the funding in research to making the impact takes 17 years, and only 14% of that initial investment are actually ending up doing an impact for the patients. Likely those numbers are somewhat less by now, but it's still the basic problem, and we want to address it as a two-part problem, getting the technology to the researchers and them building the clinical knowledge and being able to bring that to the patients. When I looked at what the challenges were, and I found a publication from 2007, or even a bit older. However, I think the problems are still very much true. High costs, intensive time demands, high level of staff expertise being required. If it's difficult to learn or not well packaged, if it's not developed to the user's needs, and if it's highly specific or only addresses the fractions of settings or populations, and particularly for the research market, if it's not modularized or customizable. We do believe that FMEARs is uniquely well, or very well at least, positioned to overcome those barriers because it is a low-cost imaging technology. The learnability is very high, as there are a lot of resources by now available. It's easy to use this technology, does a lot of the hard task. The accessibility is very good. It's portable, variable, self-sustaining. It's certainly versatile, and the use constraints have become very low. The system can be used in about any setting and in all types of population, from premature babies to elderly. And without specifically addressing the barriers, this has additional advantages. It's a real-time signal. The can be used in brain imaging, but you could image any other tissue as long as it's not too deep. And the signal has a very high information content at the moment. Most researchers, 95%, focus on the spot-like response, but we know that the hemoglobin signal also speaks to oxygen homeostasis or inflammation, and there are other use cases that are being explored. And due to those factors, FMEAR has become highly successful in research, and this is just a quick search that I used brain and FMEAR on PubMed, so it's certainly not all of it, but what I hope it illustrates nicely is that we see year to year an increase in publications. An ever-growing part of those publications is done by researchers using our system, and hence I would like to give a quick introduction of the capabilities of our research platform. This is one of the systems which you can stack up to 5 devices and record 80 sources, 75 detectors, 80 short channels with up to 8 wavelengths. You could record up to 250 Hz, and this would give you a whole head high density recording. It is using high powered light sources and very sensitive detectors down to 30 picowatt sensitivity, which gives you a very big dynamic range that we can work with, and hence it allows for an easy setup. And we have a software shown in a second that does an automatic adjustment, and hence the whole setup process maybe takes 2 minutes. We're seeing here recording from 1 subject, but we could record up to 10 subjects at the same time in a hyperscanning fashion. How we achieved to get to such a system, in all fairness, we are standing on the shoulders of giants. We are looking to the technology developing industry and getting inspired and getting the latest technology in sensors or LiDAR technology. We're working with inventors. Professor Bohr spoke before, and we're working together with him to achieve milestones of his R01 grant. But then we take this technology and build a very open platform where technology can be used. People can use it to build their own technology, and we can integrate that fairly quickly. We build those devices and then make sure it integrates also well with the rest of the research environment, like multi-model integration, integrating it with eye trackers, EEG, making it so you can use it inside the fMRI, or we would use it together with TMS. Another very important factor for researchers is having powerful analysis tools at their hands. And we're very proud and happy to work with leading groups in this field, like the HOMA, and have tools that we're well integrated with, like the HOMA 3 software from the BU Neurophotonics Center, or the FMEAR toolbox from Professor P.Britz lab. We are also working with industry from other modalities, like Dr. Tim Mullen's company, certainly a leader in automated EEG analysis, now has added pipelines for automated FMEAR analysis, or Professor Rainer Goebel's brain innovation software that just has released software called Satori, which is the fMRI version of this software. All of that is taken by NIRIX and put together in a solution that we then offer to researchers, fundamental or clinical researchers. The timeline on that is taking invention from, or having technology from inventors and integrating that, licensing it. Takes 6 months, but anything up to several years. Building a product takes a year, a little bit more than that, to have it market ready with everything. Integrating with other technologies and making sure it's well integrated into software and that there are learning resources maybe takes another 6 months, and those two go in parallel. Getting it out to the researchers depends on the funding cycle. So from being available to researcher being able to have it in their hands usually takes a year. And once they get the box, from getting it to being able to record your first subject, that takes a day, a week, but so it's definitely very fast. And then from recording your first subject to publishing your first paper, that's a number we at NIRIX track. And we know in 2019, it was just above 12 months. Unfortunately, for known reasons, in 2020, that number went up quite a lot. The barriers that we see, and here my first wish, if I could have one barrier removed, whenever we license technology, we feel like reinventing the wheel. It's the researcher, the inventor wants us to use the technology. We want to use the technology, but by the time the legal departments and our lawyers have talked, at least 6 months, and it takes a lot of resources. And in the end, those contracts all look fairly the same. So I wonder, like, we have standard for data formats or so. If there could be a standard, I think that would accelerate at this position. The other things I have to say work fairly well and leads to a rapid adoption of technology into research. And this is just a selection of the research topics that customers are working on, like methods development and fundamental research. And in clinical research, we have already a range of applications. Some of them are like the stroke detection and tinnitus, well on the way to becoming a clinical reality. And I would like to give a big shout out here at the NIH. The funding mechanism and tools that are available are very successful here, because there is, from doing a little pilot study to multi-center longitudinal study, there are tools available for that. So the things that researchers want to do with our equipment usually can be done, and that is something very, very positive. However, if we are now getting to bringing this technology, this clinical understanding into a clinical reality, we have to address the so-called valley of death, because it takes a lot of resources and time to get this clinical understanding plus technology to a clinical application. And it's supposedly only 1 of 4 or 1 out of 10, depending where you look, of the companies are successful, which points also to the fact that a company like NIREX should not attempt to cross this valley, because we have worldwide 1,000 researchers depending on us, and we should not engage in such a gamble. And there is, maybe there are funding mechanisms for crossing that, but I'm not aware, or when I talk to customers, they're not aware of having a mechanism that would be straightforward to address this situation. And one successful way of crossing it that I can refer to is working with a group of, or bringing together expertise from these clinical researchers, the technology group, that would be NIREX, and a big company that has already established a clinical product and clinical distribution. And one has to understand that being a clinical company is just more than, it's not just a clinical product. The whole company has to follow regulations. And we know from the FMEAR market that once you do that, that innovation becomes very, very hard. So a company like NIREX would try to avoid being stuck in that. So in conclusion, I would like to point out one more time, it would be very helpful if there would be a standard for licensing, that this process, we could really save some time. I also want to say thanks again for having the tools that allow us to disseminate technology into the research market. I am looking for more tools that would allow facilitation of collaboration and bringing together such innovation ecosystems to cross the valley. And last but not least, I want to say thanks again for being here. It's very nice to be part of such a positive group that all share the goal of making a positive impact on people's life. Thanks so much. And I'm looking forward to your questions.